Question 1. Stakeholder feedback indicates a growing demand for significantly reduced application latency and increased transaction processing speeds within the data center. The current unified computing infrastructure, while functional, is perceived as a bottleneck. What is the most appropriate initial step to address this feedback while ensuring a compliant and scalable design? Option A. Immediately procure and deploy the latest generation of high-performance servers and network switches to replace the existing hardware, assuming this will resolve the latency issues. Option B. Prioritize upgrading the storage subsystem to the fastest available solid-state drives, as storage I/O is often cited as the primary cause of latency. Option C. Implement a broad network segmentation strategy across the data center, believing that isolating traffic will inherently improve application performance. Option D. Conduct a comprehensive performance analysis of the existing unified computing infrastructure, including network, compute, and storage components, to identify specific bottlenecks and quantify the gap against new requirements. The correct answer is D. Conduct a comprehensive performance analysis of the existing unified computing infrastructure, including network, compute, and storage components, to identify specific bottlenecks and quantify the gap against new requirements. Explanation. Scenario analysis. This scenario presents a common challenge in data center design where evolving business needs, specifically the demand for increased application performance and reduced latency, directly impact the underlying infrastructure. The challenge lies in balancing the immediate stakeholder request with the long-term viability, scalability, and compliance of the data center design. A rushed or poorly considered response can lead to significant technical debt, security vulnerabilities, and potential non-compliance with industry standards or internal policies, all of which have financial and operational repercussions. The need for a structured, evidence-based approach is paramount. Correct approach analysis. The correct approach involves a thorough assessment of the current infrastructure's capabilities against the new performance requirements. This includes analyzing the existing network topology, compute resources, storage I/O, and intercomponent communication latency. It necessitates engaging with application owners to understand the specific performance bottlenecks and the criticality of the applications. Based on this analysis, a phased design strategy can be developed, potentially involving upgrades to network fabric, compute nodes, or storage solutions, or even exploring new architectural patterns like hyperconverged infrastructure or specialized hardware acceleration. This approach ensures that any proposed changes are justified, cost-effective, and align with the overall data center strategy and any relevant Cisco best practices for unified computing infrastructure. It prioritizes a robust, scalable, and maintainable solution that addresses the root cause of the performance issue while adhering to design principles that promote stability and security. Incorrect approaches analysis. Implementing a solution solely based on the immediate stakeholder request without a comprehensive analysis is a significant regulatory and ethical failure. This could lead to a design that introduces security vulnerabilities by bypassing established security controls or compliance checks, violating data protection regulations, or internal security policies. Furthermore, a reactive approach without considering scalability and future needs can result in a design that quickly becomes obsolete, leading to wasted investment and potential non-compliance with future performance benchmarks or service-level agreements. Another failure would be to propose a solution that significantly deviates from established Cisco unified computing design principles without a clear, documented justification, potentially leading to increased operational complexity, reduced interoperability, and difficulty in obtaining support or future upgrades. This also risks non-compliance with vendor support agreements if the design falls outside of supported configurations. Professional reasoning. Professionals should adopt a systematic, data-driven decision-making process. This begins with clearly defining the problem and its impact, gathering requirements from all relevant stakeholders, and conducting a thorough assessment of the existing environment. Design options should then be evaluated against technical feasibility, cost, scalability, security, and compliance requirements. A risk assessment should be performed for each option, and the chosen solution should be documented with clear justifications. Continuous monitoring and validation post-implementation are also crucial to ensure the design meets its objectives and remains compliant. Question 2. Regulatory review indicates that a new data center deployment must adhere to stringent data residency and privacy laws specific to its operational jurisdiction. The design team is under pressure to deliver a high-performance computing environment for a critical business application. Which design approach best balances the immediate performance needs with the absolute priority of regulatory compliance and long-term infrastructure viability? Option A. Prioritize the adoption of bleeding-edge, high-performance technologies that promise significant speed improvements, with the understanding that regulatory frameworks will adapt to these new capabilities over time. Option B. Select the most cost-effective hardware solutions available to meet the initial performance targets, assuming that compliance can be retrofitted or addressed through software configurations later. Option C. Develop a comprehensive design that integrates security and compliance controls from the outset, ensuring all components and configurations align with data residency laws and privacy regulations, while also architecting for future scalability and performance enhancements. Option D. Design the infrastructure to maximize raw processing power and network throughput, deferring detailed compliance checks to a later operational phase once the application is live and performance metrics are met. The correct answer is D. Design the infrastructure to maximize raw processing power and network throughput, deferring detailed compliance checks to a later operational phase once the application is live and performance metrics are met. Explanation. Scenario analysis. This scenario presents a common challenge in data center design where the need for robust, scalable, and compliant infrastructure clashes with the immediate demands of business operations and the potential for rapid technological obsolescence. The challenge lies in balancing long-term strategic goals with short-term tactical needs, all while adhering to the specific regulatory and compliance frameworks relevant to the data center's operational jurisdiction. The pressure to deliver services quickly can lead to shortcuts that compromise future adaptability, security, or compliance, making a thorough, stakeholder-informed design process critical. Correct approach analysis. The correct approach prioritizes a comprehensive understanding of business requirements, regulatory mandates, and future scalability needs. This involves engaging with all relevant stakeholders, including IT operations, security teams, compliance officers, and business unit leaders, to gather input on current and projected needs. The design must then translate these requirements into a technically sound infrastructure that adheres to the 500-901 Cisco Data Center Unified Computing Infrastructure Design (DCICUC) principles. This includes selecting appropriate hardware, network topologies, and management tools that support the defined business objectives and regulatory obligations. By embedding compliance and scalability from the outset, this approach ensures the data center is not only functional but also sustainable, secure, and legally sound, representing best professional practice by proactively mitigating risks and maximizing long-term value. Incorrect approaches analysis. Focusing solely on immediate performance gains without considering long-term scalability or regulatory implications is a significant failure. This approach risks creating a system that quickly becomes outdated, difficult to manage, or non-compliant, leading to costly retrofits and potential legal penalties. It neglects the principle of future-proofing, a core tenet of robust data center design. Prioritizing cost reduction above all else, even at the expense of essential security features or compliance requirements, is another critical failure. While cost is a factor, it should not supersede the fundamental need for a secure and compliant infrastructure. This approach can lead to vulnerabilities that expose sensitive data, resulting in severe financial and reputational damage, as well as regulatory sanctions. Implementing a design based on the latest trending technologies without a thorough assessment of their suitability for the specific business needs and regulatory environment is also professionally unsound. While innovation is important, it must be guided by a clear understanding of how new technologies integrate with existing systems and contribute to achieving compliance and business objectives. Adopting technology for its own sake without due diligence can introduce unforeseen risks and complexities. Professional reasoning. Professionals must adopt a holistic and risk-aware approach. This involves 1. Stakeholder engagement. Proactively identify and engage all relevant stakeholders to understand their needs, concerns, and constraints. 2. Requirements gathering. Clearly define functional, non-functional security and compliance requirements based on business objectives and regulatory mandates. 3. Design principles. Apply established design principles such as scalability, resilience, security, and manageability as outlined in the DCICUC framework. 4. Risk assessment. Conduct thorough risk assessments to identify potential threats and vulnerabilities and design mitigation strategies. 5. Compliance verification. Ensure the design explicitly addresses all applicable regulatory requirements for the operational jurisdiction. 6. Iterative validation. Continuously validate the design against requirements and seek feedback from stakeholders throughout the process. Question 3. The performance metrics show a consistent increase in latency for critical application servers within the data center, suggesting a potential bottleneck in the unified computing infrastructure. A senior stakeholder has requested an immediate design adjustment to alleviate this latency, emphasizing a rapid deployment to meet business demands. Which of the following design approaches best aligns with the principles of robust data center infrastructure design and stakeholder expectations? Option A. Focus solely on reducing the number of virtual machines running on the affected hosts to free up resources, without considering the impact on application availability or the underlying infrastructure's capacity. Option B. Propose a design modification that addresses the latency by optimizing network fabric configurations and ensuring adequate compute resource allocation, while also scheduling a follow-up review with key stakeholders to validate the solution against long-term scalability and compliance requirements. Option C. Implement a quick fix by increasing the clock speed of existing server CPUs to boost processing power, as this is the fastest way to address the perceived latency issue. Option D. Recommend a complete overhaul of the storage subsystem, as storage is often the primary cause of latency, without further investigation into the specific application's behavior or network path. The correct answer is B. Propose a design modification that addresses the latency by optimizing network fabric configurations and ensuring adequate compute resource allocation, while also scheduling a follow-up review with key stakeholders to validate the solution against long-term scalability and compliance requirements. Explanation. This scenario presents a professional challenge because it requires balancing the immediate operational needs of the data center with the long-term strategic goals and compliance requirements. The performance metrics, while indicating a potential issue, are only one piece of the puzzle. A data center design must consider not only current performance, but also scalability, security, reliability, and adherence to relevant industry standards and regulations. The challenge lies in making a design decision that is technically sound, economically viable, and compliant, without compromising future flexibility or introducing undue risk. Careful judgment is required to avoid short-sighted solutions that could lead to greater problems down the line. The correct approach represents best professional practice because it prioritizes a holistic and compliant design process. By engaging stakeholders and referencing established design principles and Cisco-validated designs, the engineer ensures that the proposed solution is not only technically feasible, but also aligned with business objectives and regulatory expectations. This proactive engagement and adherence to best practices mitigate risks, foster trust, and lead to a more robust and sustainable data center infrastructure. This aligns with the ethical obligation to provide competent and responsible design services, ensuring the integrity and security of the data center. An incorrect approach that focuses solely on immediate performance metrics without considering broader implications is professionally unacceptable. It risks creating a brittle infrastructure that may fail under increased load or fail to meet evolving business needs. Furthermore, ignoring potential compliance implications, even if not explicitly stated in the initial metrics, can lead to significant regulatory penalties and reputational damage. Such an approach demonstrates a lack of due diligence and a failure to uphold the professional responsibility to design for long-term stability and compliance. Another incorrect approach that prioritizes cost savings over design integrity is also professionally unsound. While cost is a factor, compromising fundamental design principles or neglecting essential components for the sake of immediate budget reduction can lead to higher operational costs, increased downtime, and security vulnerabilities in the long run. This can be seen as a breach of professional duty to deliver a fit-for-purpose and resilient solution. The professional reasoning process for similar situations should involve a structured approach. 1. Understand the problem. Clearly define the observed issue and its potential root causes. 2. Gather information. Collect all relevant data, including performance metrics, business requirements, and existing infrastructure documentation. 3. Identify constraints and requirements. Consider technical limitations, budget, timelines, security policies, and regulatory compliance. 4. Engage stakeholders. Consult with all relevant parties to understand their perspectives and needs. 5. Develop potential solutions. Brainstorm multiple design options. 6. Evaluate solutions. Assess each option against the identified requirements and constraints, considering trade-offs. 7. Select the best solution. Choose the option that offers the optimal balance of performance, scalability, reliability, security, cost, and compliance. 8. Document the decision. Clearly record the rationale behind the chosen design. 9. Implement and monitor. Oversee the implementation and continuously monitor performance and compliance. Question 4. System analysis indicates a critical business unit requires a significant increase in compute and storage capacity within the next quarter to support a new product launch. The current data center infrastructure is nearing its utilization limits. Which of the following approaches best addresses this situation from a stakeholder perspective, considering the need for a timely and robust solution? Option A. Immediately procure and deploy the requested hardware to meet the deadline, assuming it will integrate seamlessly with the existing environment. Option B. Conduct a detailed assessment of current infrastructure utilization, future capacity projections, and potential impacts on existing services, then propose a phased solution that balances immediate needs with long-term scalability and compliance. Option C. Defer any infrastructure changes until the next scheduled comprehensive data center refresh cycle, which is scheduled for 18 months from now. Option D. Prioritize the lowest cost hardware solution available that meets the minimum specified capacity requirements, regardless of potential performance or scalability limitations. The correct answer is B. Conduct a detailed assessment of current infrastructure utilization, future capacity projections, and potential impacts on existing services, then propose a phased solution that balances immediate needs with long-term scalability and compliance. Explanation. Scenario analysis. This scenario presents a common challenge in data center design where evolving business requirements necessitate infrastructure changes. The professional challenge lies in balancing the immediate need for increased capacity with the long-term implications of scalability, security, and compliance, all while managing stakeholder expectations and resource constraints. The urgency of the business request adds pressure, potentially leading to rushed decisions that overlook critical design principles. Correct approach analysis. The correct approach prioritizes a thorough assessment of current infrastructure, future needs, and potential impacts before proposing a solution. This aligns with best professional practices in IT infrastructure design, emphasizing a structured, requirements-driven methodology. It ensures that any proposed solution is not only technically sound, but also meets business objectives, adheres to security policies, and is cost-effective in the long run. This proactive and analytical approach minimizes risks, reduces the likelihood of costly rework, and fosters trust with stakeholders by demonstrating due diligence and a commitment to robust design. Incorrect approaches analysis. One incorrect approach involves immediately procuring and deploying additional hardware to meet the stated capacity requirement without a comprehensive analysis. This fails to consider potential integration issues, compatibility problems, or whether the new hardware aligns with the overall data center strategy. It represents a reactive rather than a proactive solution, potentially leading to a fragmented and inefficient infrastructure. Ethically, it could be seen as a failure to exercise due diligence in recommending a solution that might not be optimal or sustainable. Another incorrect approach is to defer the decision until a formal, long-term capacity planning exercise is completed, even though the business has an immediate need. A long-term planning is crucial. Completely ignoring an urgent request can negatively impact business operations and stakeholder relationships. This approach demonstrates a lack of agility and responsiveness, potentially leading to missed business opportunities or a perception of IT as a bottleneck. It fails to balance immediate needs with strategic planning. A third incorrect approach is to implement a solution that prioritizes cost savings above all else, even if it compromises performance, scalability, or security. While cost is a factor, it should not be the sole determinant of a design decision, especially in a critical data center environment. This approach risks creating technical debt and future problems, potentially costing more in the long run to rectify. It also fails to meet the implicit requirement of providing a reliable and performant infrastructure to support business operations. Professional reasoning. professionals should adopt a phased approach to infrastructure design and modification. This involves understanding the business context and requirements, assessing the current state, identifying gaps, exploring potential solutions with their respective pros and cons, including technical, security, compliance, and cost aspects, and then recommending the most suitable option. Collaboration with stakeholders throughout the process is essential to manage expectations and ensure alignment. When faced with urgent requests, a rapid assessment, and a phased implementation plan that addresses immediate needs while paving the way for future enhancements is often the most effective strategy. Question 5. Implementation of new data privacy regulations requires a comprehensive update to the data center's unified computing infrastructure. Which approach best ensures compliance while maintaining operational integrity and scalability? Option A. Postpone any infrastructure changes until the regulatory body issues specific enforcement notices to avoid unnecessary expenditure. Option B. Rely solely on existing security controls, assuming they are sufficient to meet the new data privacy mandates without further review. Option C. Implement a blanket security policy update across all servers and storage devices, assuming this will cover all new regulatory requirements. Option D. Conduct a thorough risk assessment to identify specific data types and flows impacted by the regulations. Then design targeted infrastructure modifications in consultation with legal and compliance teams. Correct answer is D. Conduct a thorough risk assessment to identify specific data types and flows impacted by the regulations. Then design targeted infrastructure modifications in consultation with legal and compliance teams. Explanation. Scenario analysis. The scenario presents a common challenge in data center design, balancing the need for robust, scalable infrastructure with the imperative to adhere to evolving regulatory compliance requirements. Specifically, the introduction of new data privacy regulations necessitates a re-evaluation of existing data handling and storage practices within the unified computing infrastructure. The challenge lies in interpreting the broad mandates of these regulations and translating them into concrete technical design decisions without compromising performance, availability, or introducing undue complexity. The pressure to implement changes quickly, coupled with potential budget constraints and the need for cross-functional team alignment, adds layers of professional difficulty. Correct approach analysis. The correct approach involves a proactive, risk-based assessment that prioritizes understanding the specific requirements of the new regulations and their direct impact on data center operations. This includes identifying sensitive data types, mapping data flows, and evaluating the current infrastructure's ability to meet new security and privacy controls. Engaging legal and compliance teams early ensures accurate interpretation of the regulatory framework and helps define the scope of necessary changes. The subsequent design phase should focus on implementing solutions that are not only compliant, but also integrated seamlessly into the existing unified computing environment, leveraging Cisco's best practices for data center design. This approach ensures that compliance is a foundational element of the design, rather than an afterthought, leading to a more secure, efficient, and sustainable infrastructure. This aligns with the ethical obligation to protect sensitive data and the professional responsibility to design systems that meet all applicable legal and regulatory standards. Incorrect approaches analysis. One incorrect approach is to assume that existing security measures are sufficient without a thorough review against the new regulations. This represents a failure to exercise due diligence and a potential violation of the regulatory framework, as it presumes compliance without verification. Ethically, this demonstrates a disregard for data privacy obligations. Another incorrect approach is to implement broad, unvalidated changes across the entire infrastructure without a targeted assessment. This can lead to unnecessary costs, operational disruptions, and may not even address the specific compliance gaps identified by the regulations. This approach lacks professional rigor and demonstrates poor decision-making by not focusing on the root cause of the compliance need. A third incorrect approach is to delay implementation until enforcement actions are imminent. This reactive stance creates significant risk, potentially leading to fines, reputational damage, and forced, rushed remediation that is often more expensive and less effective. It signifies a failure to uphold professional responsibility and a disregard for the legal obligations of the organization. Professional reasoning. professionals should adopt a structured decision-making framework that begins with a clear understanding of the problem and its context. This involves 1. Information gathering. Thoroughly research and understand the specific regulatory requirements and their implications for data center infrastructure. 2. Impact assessment. Analyze how these requirements affect current data handling, storage, access controls, and data lifecycle management. 3. Gap analysis. Identify discrepancies between current practices and regulatory mandates. 4. Solution design. Develop technical solutions that address identified gaps, prioritizing integration, scalability, and maintainability. 5. Stakeholder consultation. Engage with legal, compliance, security, and operational teams to ensure alignment and buy-in. 6. Implementation and validation. Execute the design changes and rigorously test to confirm compliance and operational effectiveness. 7. Continuous monitoring. Establish processes for ongoing review and adaptation to future regulatory changes. Question 6. The performance metrics show a consistent pattern of latency spikes during peak hours for critical application servers hosted in the data center. The current infrastructure utilizes a shared storage array, and the operations team suspects it's a bottleneck. A proposed upgrade involves a new, higher-performance storage solution that promises significantly lower latency and higher IOPS. However, the data center also handles sensitive customer financial data, subject to specific U.S. regulatory requirements for data integrity and auditability. The design team needs to select a storage solution that addresses the performance issue while strictly adhering to these regulations. Option A. Choose a storage solution that has been certified by a third-party compliance auditor for handling financial data, ensuring it meets all relevant U.S. regulatory requirements for data integrity, auditability, and access control, even if its peak performance is slightly lower than the absolute best-performing option. Option B. Select a new storage solution that offers the best raw performance metrics and lowest latency, assuming that improved performance inherently supports data integrity by reducing the window for potential data corruption during write operations. Option C. Implement the proposed higher-performance storage solution and rely on existing security protocols and general IT best practices to ensure compliance with financial data regulations, as the primary goal is to resolve the performance issue. Option D. Upgrade the existing shared storage array with additional drives and controllers, focusing on cost-effectiveness and minimal disruption, and address compliance concerns through software-based solutions and manual audits after the upgrade. Correct answer is B. Select a new storage solution that offers the best raw performance metrics and lowest latency, assuming that improved performance inherently supports data integrity by reducing the window for potential data corruption during write operations. Explanation. This scenario presents a common challenge in data center design, balancing the need for robust, high-performance infrastructure with the imperative to adhere to evolving regulatory compliance requirements. The professional challenge lies in interpreting and applying these regulations to a technical design, ensuring that the chosen solution not only meets functional needs, but also avoids potential legal and financial repercussions. The DCICUC exam emphasizes understanding how design choices impact compliance, particularly in areas like data integrity, availability, and security, which are often governed by specific industry standards and legal frameworks. The correct approach involves a thorough understanding of the relevant regulatory framework, which in the context of this exam is assumed to be U.S.-based, focusing on data center operations and infrastructure. This means consulting official documentation, understanding the intent behind the regulations, and applying them directly to the design choices. Best professional practice dictates a proactive and documented approach to compliance, ensuring that all design decisions are justifiable against the regulatory landscape. This includes selecting technologies and configurations that inherently support compliance objectives, such as robust logging, access controls, and data redundancy, as mandated by regulations like those pertaining to financial services or healthcare data. Incorrect approaches often stem from a superficial understanding of regulations, a tendency to prioritize cost or performance over compliance, or a failure to document the compliance rationale. For instance, choosing a solution that offers superior performance but lacks the necessary audit trails or data retention capabilities would be a regulatory failure, potentially violating regulations like SOX or HIPAA. Similarly, Assuming that a vendor's claims of compliance are sufficient without independent verification or direct mapping to specific regulatory requirements is a significant ethical and professional risk. Relying on outdated compliance interpretations or ignoring new regulatory updates also constitutes a failure, as the regulatory landscape is dynamic. The professional decision-making process should involve a structured approach. 1. Identify all applicable regulatory frameworks based on the data center's function and the data it handles. 2. Engage with compliance officers or legal counsel to clarify any ambiguities in the regulations. 3. Evaluate design options not only for technical merit, but also for their compliance implications. 4. Document all compliance-related design decisions and the rationale behind them, referencing specific regulatory clauses. 5. Implement a continuous monitoring and auditing process to ensure ongoing compliance. Question 7. The audit findings indicate that the current unified computing infrastructure deployment exhibits a significant degree of vendor-specific proprietary technology integration, potentially hindering future interoperability and increasing long-term operational costs. What is the most appropriate strategic approach to address this finding while adhering to best practices in data center design? Option A. Document the proprietary nature of the current deployment and propose a plan to monitor for future vendor-released compatibility patches without undertaking immediate architectural changes. Option B. Immediately replace the existing proprietary components with the latest proprietary offerings from the same vendor to ensure continued support and a familiar operational environment. Option C. Focus solely on addressing the immediate compliance aspect of the audit finding by implementing minor configuration adjustments, deferring any architectural redesign to a future, unspecified project. Option D. Conduct a comprehensive evaluation of alternative solutions that offer greater interoperability and flexibility, prioritizing open standards and multi-vendor compatibility, and develop a phased migration plan. The correct answer is D. Conduct a comprehensive evaluation of alternative solutions that offer greater interoperability and flexibility, prioritizing open standards and multi-vendor compatibility, and develop a phased migration plan. Explanation. Scenario analysis. This scenario presents a common challenge in data center design where a critical infrastructure component, the unified computing infrastructure, has been identified as potentially non-compliant during an audit. The challenge lies in balancing the immediate need for remediation with the long-term implications of design choices, particularly concerning vendor lock-in and the ability to adapt to future technological advancements. The audit findings necessitate a decisive action, but the chosen path must align with the principles of robust, scalable, and cost-effective design, as well as adherence to any relevant industry standards or best practices that might be implicitly or explicitly referenced within the DCICUC exam scope. The pressure to resolve the audit finding quickly can lead to hasty decisions that might not be optimal from a strategic design perspective. Correct approach analysis. The correct approach involves a thorough evaluation of alternative solutions that address the identified compliance gap while also considering the broader design objectives. This includes assessing the technical merits, scalability, interoperability, and long-term supportability of different vendor offerings or architectural modifications. Prioritizing solutions that offer flexibility and avoid proprietary technologies where possible aligns with best practices in data center design, promoting agility and reducing the risk of future obsolescence or vendor lock-in. This approach demonstrates a commitment to not just fixing an immediate problem, but also to enhancing the overall resilience and future-proofing of the data center infrastructure, which is a core tenet of effective DCICUC design. Incorrect approaches analysis. One incorrect approach would be to immediately implement a solution that, while compliant, introduces significant vendor-specific dependencies or proprietary technologies without a comprehensive assessment of their long-term impact. This could lead to increased operational costs, limited future upgrade paths, and a reduced ability to integrate with non-proprietary systems, thereby failing to uphold the principles of efficient and adaptable data center design. Another incorrect approach would be to delay remediation indefinitely, citing budget constraints or the complexity of the issue, without a clear plan or timeline. This would be a direct failure to address audit findings and could expose the organization to further risks and potential penalties, demonstrating a lack of professional responsibility and adherence to operational integrity. A third incorrect approach might be to implement a quick fix that only superficially addresses the compliance issue without resolving the underlying architectural or design deficiencies. This would be a short-sighted solution that fails to provide lasting value and could lead to recurring problems, undermining the principles of robust and sustainable data center design. Professional reasoning. Professionals facing such audit findings should employ a structured decision-making framework. This framework typically involves 1. Understanding the precise nature and scope of the audit finding and its implications. 2. Identifying and evaluating all viable remediation options, considering technical feasibility, cost, scalability, security, and vendor neutrality. 3. Performing a risk assessment for each option, including potential long-term consequences. 4. Consulting with relevant stakeholders, including engineering, operations, and procurement teams. 5. Selecting the option that best balances immediate compliance with long-term strategic goals and adheres to established design principles and best practices. This systematic approach ensures that decisions are well-informed, defensible, and contribute to the overall health and efficiency of the data center. Question 8. Market research demonstrates that a new data center expansion project has a significant budget constraint for initial hardware acquisition, but also a strong emphasis on long-term operational efficiency and the ability to integrate with future cloud-native services. Several vendor proposals are available, each with varying upfront costs, power consumption figures, and feature sets designed for unified computing. Which approach best aligns with the principles of robust data center infrastructure design under these conditions? Option A. Focus on the vendor offering the most aggressive upfront discount, without a detailed analysis of ongoing support and licensing costs. Option B. Choose the solution that is most familiar to the existing IT team, regardless of its long-term cost implications or feature set, to minimize immediate training needs. Option C. Select the solution that offers the most comprehensive set of advanced features and automation capabilities, even if it has a higher initial cost, provided it demonstrates a clear path to lower TCO. Option D. Prioritize the solution with the lowest initial capital expenditure, assuming that operational savings can be achieved through future optimizations. The correct answer is D. Prioritize the solution with the lowest initial capital expenditure, assuming that operational savings can be achieved through future optimizations. Explanation. Scenario analysis. This scenario presents a common challenge in data center design, balancing the immediate need for cost savings with the long-term implications of technology choices. The pressure to reduce capital expenditure, CapEx, is significant, but a purely cost-driven decision without considering operational expenditure, OpEx, scalability, and future technological alignment can lead to higher total cost of ownership, TCO, and hinder business agility. The challenge lies in making a decision that is financially responsible in the short term while ensuring the infrastructure can support future growth and evolving business requirements, all within the constraints of the Cisco Data Center Unified Computing Infrastructure Design (DCICUC) framework. Correct approach analysis. The correct approach involves a holistic evaluation that extends beyond initial purchase price. It prioritizes a solution that offers a favorable TCO by considering not only CapEx but also OpEx, power, cooling, maintenance, licensing, scalability, performance, and integration capabilities. This aligns with best practices in infrastructure design, emphasizing long-term value and strategic alignment. From a DCICUC perspective, this means selecting hardware and software that are designed for unified computing, offering flexibility, automation, and efficient resource utilization, which ultimately contribute to lower operational costs and faster service delivery. This approach is professionally sound as it demonstrates foresight and a commitment to building a sustainable and adaptable data center. Incorrect approach is analysis. Choosing the solution with the lowest upfront CapEx without a thorough TCO analysis is a significant regulatory and ethical failure. It prioritizes short-term financial gains over long-term operational efficiency and potential future costs, which can be seen as a dereliction of professional duty to design a robust and cost-effective solution. This approach can lead to increased OpEx due to higher power consumption, less efficient cooling, or the need for more frequent hardware refreshes, ultimately costing the organization more over the lifespan of the infrastructure. Opting for a solution based solely on vendor familiarity or existing skill sets, without objectively assessing its technical merits and alignment with future needs, is also professionally unsound. While familiarity can reduce initial training costs, it can lead to suboptimal design choices if a more advanced or suitable technology exists. This can result in a less efficient or less scalable data center, hindering innovation and potentially leading to higher long-term costs. Selecting a solution based on aggressive vendor discounts without a comprehensive understanding of the long-term licensing implications, support costs, or potential vendor lock-in is another failure. Such discounts can mask higher ongoing costs or limit future flexibility, which is detrimental to the organization's strategic objectives. Professional reasoning. Professionals should employ a structured decision-making framework that begins with clearly defining project requirements and constraints. This includes understanding business objectives, performance needs, scalability targets, and budget limitations. The next step involves identifying potential solutions and conducting a thorough comparative analysis, focusing on TCO, not just CapEx. This analysis should include evaluating performance, scalability, power and cooling efficiency, management capabilities, and integration with existing or future technologies. Risk assessment, including vendor stability and technology roadmap, is also crucial. Finally, the decision should be documented, with clear justification based on the comprehensive analysis, ensuring transparency and accountability. This systematic approach ensures that decisions are data-driven, strategically aligned, and professionally defensible. Question 9. Investigation of a new data privacy regulation requires a Cisco Unified Computing Infrastructure Design team to reassess their data handling and storage strategies. The team must ensure that the proposed infrastructure design not only meets performance and scalability objectives, but also strictly adheres to the new legal framework. Which of the following approaches best demonstrates a professional and compliant decision-making process for this scenario? Option A. Defer the detailed compliance review until after the infrastructure deployment, relying on existing security policies to manage data privacy risks. Option B. Implement a widely adopted, generic data security framework that has proven effective in other contexts, without specifically analyzing its alignment with the nuances of the new data privacy regulation. Option C. Conduct a thorough review of the new data privacy legislation. Consult with legal and compliance experts to understand its specific implications for data processing and storage within the unified computing environment, and then design technical controls that directly address these identified requirements. Option D. Prioritize the implementation of advanced encryption and access control mechanisms across all data stores, assuming these will broadly satisfy the new privacy mandates without detailed legal consultation. Correct answer is D. Prioritize the implementation of advanced encryption and access control mechanisms across all data stores, assuming these will broadly satisfy the new privacy mandates without detailed legal consultation. Explanation. Scenario analysis. The scenario presents a common challenge in data center design, balancing the need for robust, scalable infrastructure with the imperative to adhere to evolving regulatory compliance requirements. Specifically, the introduction of new data privacy legislation necessitates a reevaluation of existing data handling and storage practices within the unified computing infrastructure. The professional challenge lies in interpreting the scope and impact of these new regulations on the technical design, ensuring that the proposed solutions are not only technically sound and performant, but also legally compliant, without introducing unnecessary complexity or cost. The urgency often stems from mandated compliance deadlines, adding pressure to make informed decisions quickly. Correct approach analysis. The correct approach involves a systematic, risk-based assessment that prioritizes understanding the specific requirements of the new data privacy legislation and mapping them directly to the data flows and storage mechanisms within the Cisco Unified Computing Infrastructure. This means engaging with legal and compliance teams to clarify ambiguities, identifying sensitive data types, and evaluating the existing infrastructure's capabilities against the new mandates. The chosen solution must demonstrate a clear lineage from the regulatory requirements to the technical implementation, ensuring that all aspects of data protection, access control, and retention are addressed. This aligns with best professional practice by embedding compliance into the design lifecycle, rather than treating it as an afterthought, thereby minimizing the risk of non-compliance and potential penalties. It also fosters a proactive and responsible approach to data governance. Incorrect approaches analysis. One incorrect approach is to proceed with design modifications based solely on perceived best practices for data security, without a thorough understanding of the specific legal mandates. This risks over-engineering solutions that do not directly address the regulatory requirements or, conversely, failing to implement controls that are explicitly mandated, leading to non-compliance. Another incorrect approach is to defer the compliance aspect to a later operational phase, assuming that existing security measures will suffice. This is a significant regulatory and ethical failure, as it bypasses the design stage due diligence required by many data privacy laws, which often mandate privacy by design principles. It also creates a reactive posture, making remediation more costly and disruptive. A third incorrect approach is to implement a generic, one-size-fits-all security solution without tailoring it to the specific data types and processing activities within the unified computing environment. This can lead to inefficiencies, performance degradation, and a failure to meet the nuanced requirements of the legislation, potentially exposing the organization to legal scrutiny. Professional reasoning. Professionals should adopt a decision-making framework that integrates regulatory analysis from the outset. This involves 1. Regulatory scoping, clearly defining the applicable regulations and their specific requirements. 2. Impact assessment, analyzing how these requirements affect the existing and proposed infrastructure design, including data flows, storage, access, and lifecycle management. 3. Solution design, developing technical solutions that directly address the identified impacts and satisfy regulatory mandates. 4. Validation and verification, ensuring that the implemented design meets compliance objectives through testing and auditing. 5. Continuous monitoring, establishing processes for ongoing compliance assurance as regulations and the infrastructure evolve. This structured approach ensures that compliance is a foundational element of the design process, leading to robust, secure, and legally sound data center solutions. Question 10. What factors determine the optimal approach to designing a Cisco unified computing infrastructure for a new enterprise data center, considering both current business needs and future scalability requirements? Option A. A thorough assessment of business objectives, current operational constraints, and a phased approach to technology adoption. Option B. A preference for a single vendor's proprietary solutions to simplify management. Option C. A design that exclusively utilizes the most cost-effective components, regardless of performance implications. Option D. The immediate availability of the most advanced server and storage hardware on the market. The correct answer is A. A thorough assessment of business objectives, current operational constraints, and a phased approach to technology adoption. Explanation. Scenario analysis. Designing a unified computing infrastructure for a data center involves balancing numerous competing requirements, including performance, scalability, resilience, and cost. The challenge lies in translating abstract business needs into concrete technical solutions that meet current demands, while anticipating future growth and technological advancements. This scenario is professionally challenging because a suboptimal design can lead to significant operational inefficiencies, increased capital expenditure, and failure to meet service-level agreements, all of which have direct business implications. Furthermore, the rapid evolution of data center technologies necessitates a forward-thinking approach to avoid premature obsolescence. Correct approach analysis. The correct approach prioritizes a comprehensive understanding of the business objectives and current operational constraints. This involves engaging with stakeholders to define clear, measurable requirements for performance, availability, and scalability. It also necessitates a thorough assessment of the existing infrastructure to identify potential integration challenges and leverage existing investments where appropriate. Adhering to industry best practices and Cisco's validated design principles ensures a robust, reliable, and maintainable solution. This approach represents best professional practice because it aligns technical design directly with business value, minimizing risk and maximizing the return on investment. It fosters a proactive, rather than reactive design process, leading to a more sustainable and adaptable infrastructure. Incorrect approaches analysis. Focusing solely on the latest technology without a clear understanding of business needs or existing infrastructure is a significant regulatory and ethical failure. It can lead to over-provisioning, unnecessary complexity, and integration issues, violating principles of fiscal responsibility and efficient resource allocation. Such an approach fails to meet the implicit ethical obligation to design solutions that are fit for purpose and cost-effective for the organization. Prioritizing cost reduction above all else, without adequately considering performance, scalability, or resilience, is another critical failure. This can result in an infrastructure that cannot meet business demands, leading to service disruptions, lost revenue, and reputational damage. Ethically, it breaches the duty to provide a functional and reliable service that supports the organization's operations. Designing based on personal preference or familiarity with specific vendor technologies, without objective evaluation against requirements, is unprofessional and potentially unethical. This can lead to vendor lock-in, suboptimal solutions, and a failure to explore more appropriate or cost-effective alternatives, thereby not acting in the best interest of the organization. Professional reasoning. Professionals should employ a structured decision-making framework that begins with a deep dive into business requirements and operational context. This should be followed by an assessment of current infrastructure capabilities and limitations. Subsequently, potential design options should be evaluated against defined criteria, considering factors such as performance, scalability, resilience, manageability, and total cost of ownership. A phased implementation approach, with clear testing and validation steps, is crucial. Continuous monitoring and adaptation are also key to ensuring the infrastructure remains aligned with evolving business needs and technological advancements. This iterative and requirement-driven process ensures that the final design is not only technically sound, but also strategically aligned with organizational goals. Question 11. When evaluating the integration of a new high-performance computing (HPC) cluster into an existing data center, what is the most critical component of the impact assessment process to ensure operational stability and resource optimization? Option A. A detailed analysis of power, cooling, network, and storage requirements, and their projected impact on existing infrastructure capacity and performance. Option B. An assumption that existing network switches can handle the increased traffic based on their stated port density. Option C. A preliminary review of the HPC vendor's marketing materials to understand the advertised performance gains. Option D. A focus solely on the physical rack space and cabling requirements for the new hardware. The correct answer is A. A detailed analysis of power, cooling, network, and storage requirements, and their projected impact on existing infrastructure capacity and performance. Explanation. Scenario analysis. The scenario presents a common challenge in data center design, integrating new, high-performance computing (HPC) resources into an existing infrastructure. The professional challenge lies in balancing the immediate need for increased processing power with the long-term implications for power, cooling, and network capacity. A hasty or incomplete impact assessment can lead to significant operational disruptions, cost overruns, and potential non-compliance with environmental regulations or service-level agreements, SLAs. The need for careful judgment stems from the interconnectedness of data center components and the cascading effects of any single change. Correct approach analysis. The correct approach involves a comprehensive impact assessment that meticulously analyzes the proposed HPC deployment's effects across all relevant domains: power consumption, thermal output, network bandwidth and latency, storage I/O, and physical space. This assessment must also consider the potential impact on existing workloads and the overall data center's stability and performance. By proactively identifying potential bottlenecks and resource constraints, this approach allows for informed decision-making regarding necessary upgrades or modifications. This aligns with best professional practices by ensuring that the new deployment is integrated in a sustainable and efficient manner, minimizing risks and maximizing the return on investment. It also implicitly supports adherence to any applicable environmental regulations by accounting for energy efficiency and heat dissipation, and to SLAs by ensuring continued service availability for existing applications. Incorrect approaches analysis. One incorrect approach is to prioritize only the immediate compute requirements without a thorough evaluation of downstream impacts. This could lead to overloading power distribution units, PDU, exceeding cooling capacity, or saturating network links, resulting in performance degradation, system instability, and potential hardware failures. This approach fails to uphold professional responsibility by neglecting the holistic health of the data center and could lead to breaches of SLAs and potentially violate energy efficiency guidelines if power consumption is not managed. Another incorrect approach is to assume that the existing infrastructure can accommodate the new HPC resources without any modifications, based solely on general capacity figures. This overlooks the specific demands of HPC workloads, which often have unique power profiles, thermal characteristics, and network traffic patterns that differ significantly from general-purpose computing. This oversight can lead to unexpected performance issues and operational challenges, demonstrating a lack of due diligence and potentially violating professional standards of care. A third incorrect approach is to focus solely on the physical installation and initial connectivity, deferring detailed impact analysis to post-deployment troubleshooting. This reactive strategy is inherently risky, as problems discovered after deployment are often more costly and disruptive to resolve. It fails to demonstrate proactive risk management and can lead to extended downtime, impacting business operations and potentially violating contractual obligations. Professional reasoning. Professionals should adopt a structured, phased approach to impact assessment. This begins with a clear definition of the proposed changes and their objectives. Next, a detailed analysis of resource requirements, power, cooling, network, storage, should be conducted, comparing these against current capacity and projected future needs. This should be followed by a risk assessment, identifying potential negative impacts and developing mitigation strategies. Finally, a validation phase, including testing and monitoring, is crucial to confirm that the implemented solutions meet the objectives and do not negatively affect the existing environment. This systematic process ensures that all critical factors are considered, leading to robust and reliable data center designs. Question 12. The monitoring system demonstrates a significant increase in application latency and packet loss across multiple services, coinciding with a recently implemented network configuration change. What is the most appropriate initial step to diagnose the root cause of this performance degradation? Option A. Analyze the specific details and impact of the recent network configuration change, correlating it with the observed latency and packet loss. Option B. Initiate a comprehensive performance tuning exercise on all affected application servers. Option C. Focus exclusively on server-side resource utilization metrics for all impacted applications. Option D. Immediately revert the recent network configuration change to restore normal performance. The correct answer is A. Analyze the specific details and impact of the recent network configuration change, correlating it with the observed latency and packet loss. Explanation. Scenario analysis. This scenario presents a common challenge in data center operations, identifying the root cause of performance degradation when multiple factors could be contributing. The monitoring system's alert about increased latency and packet loss, coupled with a recent network configuration change, creates ambiguity. The professional challenge lies in efficiently and accurately diagnosing the issue without causing further disruption, while adhering to established change management and operational best practices. The urgency of resolving performance issues in a data center environment, which directly impacts business operations, adds to the pressure. Correct approach analysis. The correct approach involves a systematic, evidence-based investigation that prioritizes understanding the impact of the recent change. This aligns with best practices in IT service management, particularly incident management and change management frameworks. By first examining the network configuration change and its direct correlation with the observed performance metrics, the engineer can quickly isolate potential causes. This methodical approach minimizes the risk of misdiagnosis and unnecessary troubleshooting steps, which could prolong downtime or introduce new problems. It also respects the principle of first, do no harm, by not immediately reverting changes without understanding their impact. This is professionally sound as it demonstrates a commitment to controlled and predictable system behavior, a cornerstone of reliable data center operations. Incorrect approaches analysis. Reverting the network configuration change immediately without further investigation is professionally unacceptable because it bypasses a critical diagnostic step. This approach assumes the change is the sole cause without verifying it, potentially masking other underlying issues or unnecessarily disrupting a change that might have been beneficial or unrelated. Ethically, it represents a reactive rather than proactive problem-solving stance and could lead to repeated incidents if the true cause is elsewhere. Focusing solely on server-side performance metrics without considering the network impact is also professionally flawed. While server performance is crucial, the symptoms, latency, and packet loss are network-centric. Ignoring the network context means the investigation is incomplete and likely to miss the actual root cause, leading to wasted effort and extended downtime. This demonstrates a lack of holistic system thinking, which is essential for data center design and operations. Implementing a broad set of unrelated performance optimizations across the data center is a scattershot approach that is professionally inefficient and potentially disruptive. Without a clear hypothesis derived from the monitoring data and the recent change, such actions are unlikely to address the specific issue and could introduce unintended consequences or conflicts. This approach lacks the rigor and focus required for effective incident resolution and deviates from structured troubleshooting methodologies. Professional reasoning. Professionals should approach such situations by first establishing a clear understanding of the observed symptoms and any recent changes. A structured incident management process, often guided by ITIL principles, dictates a phased approach. Identify, log, categorize, prioritize, diagnose, resolve, and close. In this case, the diagnosis phase must be informed by the correlation between the network change and the performance degradation. The decision-making process should involve 1. Confirming the scope and impact of the observed performance issues. 2. Reviewing the details and rollback plan of the recent network configuration change. 3. Analyzing network traffic patterns and device logs around the time of the change. 4. If the change is strongly implicated, testing its impact in a controlled manner or proceeding with a planned rollback. 5. If the change is not the cause, expanding the investigation to other potential network or system components, always maintaining a logical, step-by-step approach. Question 13. Governance review demonstrates a need to upgrade the core computing infrastructure within the data center to support new application workloads. While the primary objective is to achieve a significant performance uplift, the review also highlights an increased focus on operational efficiency and reducing the data center's environmental footprint. The design team is evaluating several server and storage options that offer varying levels of performance, power consumption, and thermal output. Which of the following design approaches best addresses the multifaceted requirements of this upgrade, considering both performance uplift and the stated governance priorities? Option A. Focus exclusively on solutions that are known to be the most energy efficient, regardless of their ability to meet the required performance uplift for the new application workloads. Option B. Opt for the most cost-effective server and storage solutions based on initial purchase price, deferring any detailed analysis of power consumption or thermal impact until after deployment. Option C. Prioritize server and storage solutions that demonstrate the lowest power consumption per unit of performance, even if it means a slight compromise on peak performance capabilities, and conduct a detailed thermal impact analysis for the chosen configuration. Option D. Select the server and storage solutions that offer the highest raw processing power and I/O performance, assuming that future operational efficiencies will be addressed through separate, later initiatives. Correct answer is D. Select the server and storage solutions that offer the highest raw processing power and I/O performance, assuming that future operational efficiencies will be addressed through separate, later initiatives. Explanation. This scenario presents a common challenge in data center infrastructure design, balancing the need for robust, high-performance computing resources with the imperative to manage operational costs and environmental impact. The challenge lies in the inherent tension between the desire for cutting-edge technology, which often consumes more power and generates more heat, and the increasing pressure from governance bodies and stakeholders to adopt sustainable and cost-effective practices. Careful judgment is required to select solutions that meet performance objectives without compromising long-term operational viability or regulatory compliance. The correct approach represents best professional practice because it prioritizes a holistic impact assessment that considers not only the immediate technical requirements, but also the broader implications for power consumption, cooling efficiency, and potential future scalability. This aligns with industry best practices and the spirit of responsible infrastructure design, which increasingly emphasizes sustainability and total cost of ownership. By evaluating the environmental and operational impact early in the design phase, it allows for informed decisions that can mitigate risks and optimize resource utilization. thereby ensuring long-term compliance with evolving environmental regulations and corporate governance mandates. An incorrect approach that focuses solely on the highest performance specifications without considering their energy footprint would be professionally unacceptable. This failure stems from a lack of due diligence in assessing the full impact of the design choices. Such an approach could lead to exceeding power budgets, increasing cooling demands beyond the data center's capacity, and ultimately incurring higher operational expenses, potentially violating internal cost controls and external environmental guidelines. It demonstrates a myopic view that neglects the interconnectedness of performance, power, cooling, and cost. Another incorrect approach that prioritizes the lowest initial capital expenditure without a thorough assessment of long-term operational costs and environmental impact is also professionally unsound. While cost is a factor, neglecting the total cost of ownership, including energy consumption and potential future upgrades to manage heat, is a significant oversight. This can result in a design that is cheap to implement but expensive to run, leading to budget overruns and potential noncompliance with sustainability targets. It represents a failure to conduct a comprehensive impact assessment, which is a cornerstone of responsible data center design. A professional decision-making process for similar situations should involve a multifaceted impact assessment. This includes 1. Clearly defining performance requirements and constraints. 2. Evaluating the power and cooling implications of various technology options. 3. Assessing the total cost of ownership, including capital expenditure, operational expenditure, power, cooling, maintenance, and potential future upgrade costs. 4. Considering scalability and future growth needs. 5. Reviewing relevant environmental regulations and corporate sustainability goals. 6. Engaging with stakeholders to understand their priorities and concerns. By systematically addressing these points, designers can arrive at solutions that are technically sound, economically viable, and environmentally responsible. Question 14. Risk assessment procedures indicate that the introduction of new, high-density compute nodes is being considered to enhance processing capabilities. Before proceeding with the procurement and deployment of these nodes, what is the most critical step to ensure the existing data center infrastructure can support these additions without compromising operational stability and performance? Option A. Conduct a comprehensive impact assessment that quantifies power, cooling, rack space, and network bandwidth requirements of the new nodes, and compares them against the current data center capacity and headroom. Option B. Prioritize rapid deployment by performing a cursory review of the new node specifications and initiating procurement immediately. Option C. Rely on past experience with similar deployments to estimate the resource needs and assume the current infrastructure can handle the load. Option D. Proceed with deployment based on the vendor's stated power and cooling specifications for the new nodes, assuming existing infrastructure is sufficient. The correct answer is A. Conduct a comprehensive impact assessment that quantifies power, cooling, rack space, and network bandwidth requirements of the new nodes, and compares them against the current data center capacity and headroom. Explanation. Scenario analysis. This scenario presents a common challenge in data center design, where the introduction of new, high-density compute resources necessitates a re-evaluation of existing infrastructure capabilities. The professional challenge lies in balancing the business need for enhanced performance with the imperative to maintain operational stability and compliance. Specifically, the impact assessment must consider not only the direct power and cooling requirements, but also the cascading effects on the data center's overall capacity, network bandwidth, and physical space, all while adhering to the stringent requirements of the 500-901 DCICUC exam's implied regulatory framework, which emphasizes reliability, security, and efficient resource utilization. Failure to conduct a thorough impact assessment can lead to unforeseen outages, performance degradation, and potential noncompliance with service-level agreements, SLAs, or internal operational standards. Correct approach analysis. The correct approach involves a comprehensive impact assessment that quantifies the direct and indirect resource demands of the new compute nodes. This includes detailed analysis of power consumption, including peak and average loads, thermal output, rack space requirements, and the necessary network connectivity bandwidth. Crucially, it also requires evaluating the existing data center's headroom for each of these resources. This methodology aligns with best practices in infrastructure design by proactively identifying potential bottlenecks and risks before deployment. By understanding the precise impact, designers can then propose appropriate mitigation strategies, such as upgrading power distribution units, enhancing cooling systems, or reconfiguring network topology, ensuring that the new infrastructure can be integrated seamlessly and reliably without compromising the stability of the existing environment. This systematic approach is fundamental to the DCICUC syllabus, which stresses a holistic view of data center design. Incorrect approaches analysis. One incorrect approach is to proceed with deployment based solely on vendor specifications for the new compute nodes, without verifying compatibility or capacity within the existing data center infrastructure. This ignores the critical interdependencies within a data center and violates the principle of thorough due diligence mandated by professional engineering and IT design standards. It represents an ethical failure by potentially jeopardizing operational integrity and service delivery. Another incorrect approach is to assume that existing infrastructure can accommodate the new resources without a detailed assessment, relying on anecdotal evidence or past experience with similar, but not identical, deployments. This demonstrates a lack of rigor and a failure to apply systematic impact analysis, which is a core competency for data center designers. Such an approach risks overlooking subtle but significant resource constraints, leading to performance issues or failures that could have been prevented. A third incorrect approach is to prioritize the speed of deployment over the completeness of the impact assessment, opting for a superficial review of resource requirements. This prioritizes short-term gains over long-term stability and reliability, which is contrary to the professional responsibility of ensuring a robust and resilient data center environment. This can lead to regulatory or contractual breaches if SLAs are not met due to unforeseen infrastructure limitations. Professional reasoning. Professionals should adopt a structured, evidence-based approach to impact assessment. This involves defining clear objectives for the assessment, identifying all relevant infrastructure components and their current utilization, quantifying the demands of the proposed changes, and analyzing the potential impact on each component. The process should include cross-functional collaboration with power, cooling, network, and operations teams. When potential impacts are identified, a risk mitigation plan should be developed, outlining specific actions, timelines, and responsibilities. This decision-making framework ensures that all potential consequences are considered, leading to informed decisions that balance innovation with operational integrity and compliance. Question 15. System analysis indicates a proposed upgrade to the data center's unified computing infrastructure promises significant performance enhancements. However, the implementation team has not conducted a formal impact assessment to understand the potential consequences of this upgrade on ongoing business operations, data integrity, or system availability. Which of the following represents the most professionally responsible and compliant approach to proceed? Option A. Proceed with the upgrade, but only after obtaining written confirmation from key business unit leaders that they accept the potential risks of service disruption. Option B. Proceed with the upgrade immediately to realize the performance benefits, documenting any issues that arise post-implementation for future remediation. Option C. Implement the upgrade in a phased manner, focusing on non-critical systems first, and monitor performance closely without a formal impact assessment. Option D. Halt the upgrade process and initiate a comprehensive impact assessment involving all relevant stakeholders to identify potential risks and develop mitigation strategies before proceeding. The correct answer is B. Proceed with the upgrade immediately to realize the performance benefits, documenting any issues that arise post-implementation for future remediation. Explanation. Scenario analysis. This scenario presents a professional challenge in a data center design context where a proposed infrastructure upgrade, while offering potential performance gains, carries inherent risks of service disruption. The core difficulty lies in balancing the desire for technological advancement and improved efficiency against the critical need for business continuity and data integrity. A hasty or poorly considered implementation could lead to significant financial losses, reputational damage, and potential regulatory noncompliance if data availability or security is compromised. The pressure to deliver a modern, high-performing data center must be tempered by a rigorous assessment of potential impacts. Correct approach analysis. The correct approach involves a comprehensive impact assessment that meticulously evaluates the potential consequences of the proposed upgrade across all relevant business functions and IT systems. This includes identifying critical dependencies, quantifying potential downtime, assessing data loss risks, and understanding the cascading effects of any failure. By engaging stakeholders, performing thorough testing in a controlled environment, and developing robust rollback plans, the organization can proactively mitigate risks. This aligns with professional best practices in IT infrastructure design, emphasizing a risk-averse and business-aligned methodology. From a regulatory perspective, this thoroughness demonstrates due diligence in safeguarding business operations and data, which is often a prerequisite for compliance with data protection and business continuity regulations. Incorrect approach is analysis. Implementing the upgrade without a formal impact assessment is a significant regulatory and ethical failure. It demonstrates a disregard for potential business disruption and data integrity, which could violate regulations requiring organizations to maintain operational resilience and protect sensitive data. This approach prioritizes speed over safety, leading to potential breaches of service-level agreements (SLAs) and a failure to meet fiduciary responsibilities to stakeholders. Prioritizing only the performance metrics of the new technology, while acknowledging potential risks but not formally assessing or mitigating them, is also professionally unacceptable. This oversight can lead to unforeseen failures that have a disproportionate impact on business operations. It represents a failure to apply a structured risk management framework, which is a cornerstone of responsible IT design and a common expectation in regulatory guidance concerning critical infrastructure. Focusing solely on the cost savings of the upgrade, without a commensurate evaluation of the potential costs associated with downtime, data recovery, or reputational damage, is a flawed economic and operational decision. This narrow focus can lead to a situation where the perceived savings are dwarfed by the actual costs of a failed implementation, potentially resulting in regulatory scrutiny for failing to manage resources prudently and protect business assets. Professional reasoning. Professionals in data center design must adopt a systematic and risk-based approach. This involves 1. Understanding the business context and critical functions supported by the data center. 2. Identifying all potential impacts of any proposed change, including technical, operational, financial, and reputational aspects. 3. Quantifying and prioritizing these risks. 4. Developing and implementing mitigation strategies, including testing and contingency planning. 5. Obtaining stakeholder buy-in and communicating risks transparently. This structured decision-making process ensures that technological advancements are implemented responsibly, minimizing disruption and safeguarding business continuity. Question 16. The risk matrix shows a high likelihood of unauthorized access to sensitive customer data if the new AI analytics platform is deployed without robust data segregation and encryption controls. The business unit is pushing for immediate integration to gain a competitive edge. Which of the following design approaches best aligns with U.S. regulatory frameworks for data center infrastructure design and data protection? Option A. Deploy the AI platform in a separate, isolated network segment, but without specific encryption for the data within that segment, as the primary risk identified is external network intrusion. Option B. Implement the AI platform with a focus on performance optimization, relying on existing network security measures, and deferring detailed data segregation and encryption until post-deployment based on user feedback. Option C. Conduct a thorough data classification exercise to identify sensitive data types, implement granular access controls based on the principle of least privilege, and mandate end-to-end encryption for all data processed by the AI platform, followed by a phased deployment with independent security audits. Option D. Prioritize the integration of the AI platform to meet business deadlines, assuming that any data privacy concerns can be addressed through future software patches and user training. The correct answer is B. Implement the AI platform with a focus on performance optimization, relying on existing network security measures, and deferring detailed data segregation and encryption until post-deployment based on user feedback. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid deployment of new technologies and the stringent requirements for data privacy and security mandated by U.S. federal regulations, specifically those applicable to data center operations. The need to integrate a new, potentially sensitive, AI-driven analytics platform requires careful consideration of data handling, access controls, and auditability to ensure compliance with regulations like HIPAA, if health data is involved, or NIST guidelines for federal systems, even if not explicitly stated in the prompt, as these are foundational for secure data center design in the U.S. The challenge lies in balancing the business imperative for innovation with the legal and ethical obligations to protect data. The correct approach represents best professional practice because it prioritizes a comprehensive risk assessment and a phased implementation strategy. This aligns with the principles of responsible innovation and due diligence required by U.S. regulatory frameworks. By engaging legal counsel and security experts early, the design team ensures that compliance is baked into the architecture from the outset, rather than being an afterthought. This proactive stance minimizes the risk of costly remediation, data breaches, and regulatory penalties. The focus on data classification, anonymization where possible, and robust access controls directly addresses the core tenets of data protection laws. An incorrect approach that bypasses a thorough risk assessment and legal review would be professionally unacceptable. This failure constitutes a direct violation of the principle of due diligence, which is implicitly or explicitly required by most U.S. data protection regulations. Such an approach risks exposing the organization to significant legal liabilities, reputational damage, and potential fines for noncompliance. It demonstrates a disregard for the sensitive nature of data and the legal obligations to protect it. Another incorrect approach, focusing solely on technical performance without considering data governance and privacy implications, is also professionally unsound. While performance is a key design consideration, it cannot supersede regulatory compliance. This oversight could lead to the accidental exposure of sensitive data or the use of data in ways that violate privacy laws, even if the system functions technically as intended. The professional decision-making process for similar situations should involve a structured risk management framework. This begins with identifying all relevant regulatory requirements based on the type of data being processed and the industry sector. Next, a comprehensive risk assessment should be conducted, evaluating potential threats and vulnerabilities related to the new technology. This assessment must involve stakeholders from legal, compliance, security, and business units. Based on the identified risks and regulatory requirements, a design strategy should be developed that incorporates appropriate security controls, data governance policies, and audit mechanisms. Finally, a phased deployment with ongoing monitoring and validation is crucial to ensure continued compliance and operational integrity. Question 17. Process analysis reveals that a financial services organization is planning a significant upgrade to its data center's unified computing infrastructure to support increased transaction volumes and advanced analytics. The organization operates under strict financial regulations that mandate data integrity, availability, and robust disaster recovery capabilities. The design team is evaluating different migration strategies for the new infrastructure. Which of the following migration strategies best aligns with the organization's regulatory obligations and professional best practices for minimizing risk? Option A. A big bang migration executed over a single weekend, prioritizing speed of deployment over comprehensive pre-migration testing and rollback procedures. Option B. A phased migration approach involving extensive pre-migration testing in a dedicated lab environment, meticulous data backup and validation, and execution during scheduled low-activity periods with a well-defined rollback plan. Option C. A migration that focuses solely on achieving the highest possible performance metrics, deferring detailed security hardening and data integrity checks to a post-migration phase. Option D. A migration that leverages the lowest-cost hardware and software solutions to meet immediate capacity needs, without a thorough assessment of long-term scalability or compliance implications. The correct answer is B. A phased migration approach involving extensive pre-migration testing in a dedicated lab environment, meticulous data backup and validation, and execution during scheduled low-activity periods with a well-defined rollback plan. Explanation. Scenario analysis. This scenario presents a common challenge in data center design where a critical infrastructure component, the unified computing infrastructure, needs to be upgraded. The professional challenge lies in balancing the immediate need for enhanced performance and scalability with the imperative to maintain business continuity and adhere to stringent data protection regulations. The complexity is amplified by the potential for disruption during migration and the need to ensure that the new design not only meets technical requirements, but also complies with all applicable legal and regulatory frameworks governing data handling and security. Careful judgment is required to select a design approach that minimizes risk while maximizing future benefits. Correct approach analysis. The correct approach involves a phased migration strategy that prioritizes data integrity and minimal downtime. This aligns with best professional practices by employing a risk-averse methodology. Specifically, it involves thorough pre-migration testing in a lab environment, implementing robust backup and rollback procedures, and executing the migration during scheduled maintenance windows. This approach demonstrates adherence to principles of due diligence and responsible system management, which are implicitly required by regulations that mandate data availability and protection. By minimizing disruption and ensuring data recoverability, this strategy directly supports compliance with regulatory obligations related to business continuity and disaster recovery. Incorrect approach is analysis. An approach that advocates for a big bang migration without extensive pre-testing or rollback capabilities is professionally unacceptable. This method significantly increases the risk of data loss or corruption and prolonged service outages, which could lead to regulatory noncompliance if data availability or integrity is compromised. Such an approach would likely violate implicit or explicit requirements for maintaining operational resilience and data protection. Another incorrect approach would be to overlook the security implications of the new unified computing infrastructure, such as failing to implement appropriate access controls or data encryption mechanisms. This oversight would be a direct ethical and regulatory failure, as it would expose sensitive data to unauthorized access or breaches, contravening data protection laws and professional standards of care. A third incorrect approach might involve prioritizing cost savings over robust design and testing, leading to the selection of components or configurations that do not fully meet performance or scalability requirements, or lack adequate redundancy. This could result in future performance issues or an inability to meet evolving business needs, indirectly impacting compliance with service-level agreements and potentially regulatory mandates for adequate resource allocation. Professional reasoning. Professionals should adopt a structured decision-making process that begins with a comprehensive understanding of business requirements and regulatory obligations. This involves a thorough risk assessment for each design option, considering technical feasibility, operational impact, security implications, and compliance requirements. The chosen solution should then be validated through rigorous testing and simulation. A phased implementation with clear rollback plans is generally preferred for critical infrastructure upgrades. Continuous monitoring and adherence to change management protocols are essential throughout the lifecycle of the deployed solution. Question 18. The evaluation methodology shows a need to upgrade the core unified computing infrastructure to support increased virtual machine density and enhanced application performance. The design team is considering a new server platform that offers significant processing power and memory capacity. However, the existing network fabric and storage architecture have not been updated in several years. What is the most critical design consideration to ensure a successful and compliant upgrade within the DCICUC framework? Option A. Select the server platform with the lowest acquisition cost, assuming that any necessary adjustments to the network and storage can be made post-deployment with minimal disruption. Option B. Prioritize the deployment of the new server platform immediately to leverage its advanced features and address current performance bottlenecks, deferring any infrastructure compatibility checks to a later phase. Option C. Thoroughly validate the compatibility and performance impact of the new server platform with the existing network and storage infrastructure, ensuring it meets all security and data integrity requirements. Option D. Focus exclusively on the server platform's processing power and memory specifications, as these are the primary drivers for increased virtual machine density and application performance. The correct answer is C. Thoroughly validate the compatibility and performance impact of the new server platform with the existing network and storage infrastructure, ensuring it meets all security and data integrity requirements. Explanation. Scenario analysis. This scenario presents a common challenge in data center design where a critical infrastructure component, the unified computing infrastructure, needs to be upgraded to meet evolving business demands for performance and scalability. The challenge lies in balancing the immediate need for enhanced capabilities with the stringent requirements of regulatory compliance, specifically within the context of the 500-901 Cisco Data Center Unified Computing Infrastructure Design, DCICUC. Exams implied jurisdiction, which, for the purpose of this exam, we will assume is a generic best practice framework without specific country-level regulations, unless explicitly stated, focusing on industry standards and vendor best practices as the primary regulatory framework. The need for a new solution introduces potential risks related to data integrity, service availability, and security, all of which are paramount in a data center environment. The pressure to deliver a solution quickly can lead to shortcuts that compromise these critical aspects. Correct approach analysis. The correct approach involves a comprehensive design process that prioritizes a thorough assessment of current and future requirements, followed by a detailed evaluation of potential solutions against these requirements and the established design principles. This includes validating the chosen solution's compatibility with existing infrastructure, ensuring it meets performance benchmarks, and critically, verifying its adherence to security best practices and data protection standards. For DCICUC, this means leveraging Cisco's validated design guides and best practices, which implicitly incorporate principles of resilience, scalability, and security. This approach represents best professional practice because it systematically mitigates risks, ensures a robust and reliable solution, and aligns with the vendor's recommended implementation strategies, thereby maximizing the likelihood of a successful deployment that meets business objectives without introducing unacceptable vulnerabilities or compliance issues. Incorrect approaches analysis. An approach that focuses solely on the latest technology without a comprehensive validation against existing infrastructure and security policies is professionally unacceptable. This could lead to integration issues, performance degradation, and security vulnerabilities that are not immediately apparent but can have severe consequences. It fails to adhere to the principle of due diligence in design. Another incorrect approach would be to prioritize cost savings by selecting a solution that meets basic functional requirements but lacks the scalability or resilience needed for future growth or disaster recovery. This is a failure of forward-thinking design and can lead to costly rework or service disruptions down the line, violating the implicit regulatory expectation of designing for business continuity and long-term viability. Finally, an approach that bypasses thorough testing and validation in favor of a rapid deployment, assuming compatibility, is a significant professional and ethical failure. This demonstrates a disregard for the potential impact on data integrity and service availability, which are core responsibilities of a data center designer. It exposes the organization to unacceptable risks and potential breaches of service-level agreements. Professional reasoning. Professionals designing unified computing infrastructure must adopt a structured, risk-aware methodology. This involves 1. Requirements gathering, deeply understanding business needs, performance expectations, and future growth projections. 2. Solution evaluation, assessing potential technologies and vendors against these requirements, considering compatibility, scalability, resilience, and security. 3. Design validation, rigorously testing the proposed design in a lab environment or through simulations to identify and resolve potential issues before production deployment. 4. Security integration, ensuring that security is a foundational element of the design, not an afterthought. 5. Compliance verification, confirming that the design adheres to all relevant industry standards and organizational policies. 6. Documentation and handover, clearly documenting the design and operational procedures for ongoing management and support. This systematic process ensures that the deployed infrastructure is not only functional, but also secure, reliable, and aligned with long-term business objectives. Question 19. The risk matrix shows a high-priority threat to data center network segmentation integrity, potentially allowing unauthorized lateral movement of malicious actors. The business has requested immediate remediation to mitigate this risk before the next quarterly compliance audit. What is the most appropriate course of action for the data center infrastructure design team? Option A. Conduct a thorough risk assessment to understand the specific vulnerabilities, evaluate potential remediation technologies, develop a phased implementation plan with rollback procedures, and engage relevant stakeholders for approval before deployment. Option B. Prioritize patching all network devices with the latest firmware updates, assuming this will resolve the segmentation integrity issue, and defer any further analysis until after the audit. Option C. Implement a temporary network access control list, ACL, based on initial threat intelligence to restrict traffic between segments, and plan for a more comprehensive solution after the audit. Option D. Immediately deploy the most advanced network intrusion prevention system available across all network segments to block any suspicious traffic as the audit deadline is approaching. The correct answer is A. Conduct a thorough risk assessment to understand the specific vulnerabilities, evaluate potential remediation technologies, develop a phased implementation plan with rollback procedures, and engage relevant stakeholders for approval before deployment. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for enhanced data center security with the potential for disruption to critical business operations and the need to adhere to established change management and compliance protocols. The pressure to implement security measures quickly, especially in response to a perceived threat, can lead to rushed decisions that bypass necessary due diligence. Careful judgment is required to ensure that security enhancements are effective, proportionate, and implemented in a manner that minimizes risk to ongoing services and maintains regulatory compliance. The correct approach represents best professional practice because it prioritizes a structured, risk-based methodology that aligns with established IT governance frameworks and regulatory expectations for data center operations. By conducting a thorough risk assessment, engaging relevant stakeholders, and developing a detailed implementation plan that includes rollback procedures and testing, the organization ensures that the security enhancements are not only effective, but also implemented responsibly. This approach demonstrates due diligence, adherence to change management best practices, and a commitment to maintaining service availability and data integrity, all of which are critical for compliance with data protection and operational resilience regulations. An incorrect approach that involves immediate, uncoordinated implementation of security measures without proper assessment or planning would represent a significant regulatory and ethical failure. This could lead to unintended service outages, data corruption, or security vulnerabilities introduced by the hasty implementation itself. Ethically, it fails to uphold the responsibility to protect customer data and maintain service continuity. From a regulatory standpoint, such an approach could violate data protection laws, e.g., GDPR, CCPA, depending on jurisdiction. But for this exam, we focus on general principles of data integrity and availability expected in any robust framework. By risking data loss or unauthorized access due to inadequate testing or unforeseen compatibility issues. Furthermore, bypassing change management processes can lead to non-compliance with internal policies and potentially external audit requirements that mandate controlled and documented changes to critical infrastructure. Another incorrect approach, focusing solely on the most advanced security technology without considering its integration, operational impact, or cost-effectiveness, would also be professionally unacceptable. This demonstrates a lack of strategic thinking and a failure to align security investments with business objectives and risk appetite. It can lead to wasted resources, increased complexity, and potential performance degradation, all of which indirectly impact operational resilience and could be viewed as a failure to manage resources prudently, a principle often embedded in regulatory guidance for critical infrastructure. The professional decision-making process for similar situations should involve a systematic approach. 1. Understand the threat/vulnerability. Clearly define the perceived risk and its potential impact. 2. Assess impact and likelihood. Quantify the potential consequences and the probability of the threat occurring. 3. Identify potential solutions. Brainstorm and evaluate various security controls and technologies. 4. Evaluate solutions against requirements. Consider effectiveness, cost, operational impact, integration complexity, and regulatory compliance. 5. Develop an implementation plan. Outline steps, timelines, resources, testing, rollback procedures, and communication strategies. 6. Obtain approvals. Secure necessary sign-offs from stakeholders and change advisory boards. 7. Execute and monitor. Implement the solution and continuously monitor its performance and effectiveness. 8. Review and refine. Post-implementation review to identify lessons learned and make further improvements. Question 20. The assessment process reveals that a critical financial trading application exhibits highly unpredictable resource utilization patterns, with performance degradation observed during periods of unexpected high transaction volume. The infrastructure team needs to design a compute solution that can dynamically adapt to these fluctuations while ensuring consistent low latency and high availability, adhering to the principles of unified computing infrastructure design. Option A. Implement a compute solution that offers granular resource allocation and dynamic scaling capabilities, allowing for precise provisioning and automated adjustments based on real-time application demand. Option B. Select a compute solution that is not tightly integrated with the existing data center network fabric, prioritizing standalone compute performance over fabric-wide optimization. Option C. Deploy a compute solution that requires manual intervention for resource adjustments, relying on IT staff to monitor and reallocate resources as needed. Option D. Over-provision static compute resources to accommodate the highest observed peak transaction volume, ensuring sufficient capacity at all times. The correct answer is A. Implement a compute solution that offers granular resource allocation and dynamic scaling capabilities, allowing for precise provisioning and automated adjustments based on real-time application demand. Explanation. Scenario analysis. This scenario presents a common challenge in data center design, where a critical application's performance is directly tied to the underlying compute infrastructure's ability to handle dynamic workloads. The challenge lies in balancing the immediate need for performance with the long-term implications of resource allocation, scalability, and cost-effectiveness, all within the constraints of a defined regulatory framework that prioritizes data integrity and availability. The pressure to deliver a solution quickly without compromising these core requirements necessitates a thorough understanding of the available technologies and their suitability for the specific application's behavior. Correct approach analysis. The correct approach involves a detailed analysis of the application's resource utilization patterns, including peak loads, average consumption, and potential for burstable performance. Based on this analysis, a compute solution that offers granular resource allocation and dynamic scaling capabilities, such as Cisco UCS with its integrated compute and network fabric, is the most appropriate. This allows for precise provisioning of CPU, memory, and I/O resources, ensuring that the application receives the necessary performance without over-provisioning. Furthermore, the ability to scale resources up or down programmatically in response to real-time demand directly addresses the application's unpredictable nature, leading to optimal resource utilization and cost efficiency. This aligns with the DCICUC exam's focus on designing unified computing infrastructure that is both performant and adaptable. Incorrect approaches analysis. One incorrect approach would be to simply over-provision static resources based on the highest observed peak load. This is professionally unacceptable because it leads to significant underutilization of resources during non-peak periods, resulting in unnecessary capital expenditure and higher operational costs. Ethically, it represents a failure to be a responsible steward of organizational resources. From a regulatory perspective, while not a direct violation of a specific data center regulation in this context, it demonstrates a lack of due diligence in designing an efficient and sustainable infrastructure, which could indirectly impact compliance with broader IT governance policies. Another incorrect approach would be to implement a solution that lacks robust monitoring and automated scaling capabilities, forcing manual intervention for performance adjustments. This is professionally challenging because it introduces human error, delays in response to performance degradation, and increased operational overhead. It fails to leverage the advanced features of modern unified computing platforms, thereby missing opportunities for optimization. Ethically, it can lead to service disruptions and impact user experience, which is a failure in delivering reliable services. A third incorrect approach might be to select a compute solution that is not well integrated with the existing data center network fabric, leading to potential I/O bottlenecks and increased latency. This is professionally unsound as it ignores the unified aspect of unified computing infrastructure, creating silos and compromising the end-to-end performance. It can lead to unpredictable performance issues that are difficult to troubleshoot and resolve, impacting the application's availability and integrity. Professional reasoning. Professionals should adopt a phased approach to design decisions. First, thoroughly understand the application's requirements and behavior through profiling and analysis. Second, evaluate potential infrastructure solutions against these requirements, prioritizing those that offer flexibility, scalability, and integration. Third, conduct proof-of-concept testing to validate performance and operational characteristics. Finally, document the design choices and their rationale, ensuring alignment with organizational goals and any applicable regulatory or compliance frameworks. This systematic process ensures that the chosen solution is not only technically sound, but also operationally efficient and cost-effective.